Well, it's my real pleasure to be here. Thank you, Jimmy, for the overview and introduction. And my name is Edmund Ye. I'm as a professor and department chair at Electrical and Computer Engineering at Northeastern University in Boston. And I'm also founding director of the Physical AI Research Initiative. Acronym is PAIR, P-A-I-R. And today, my talk is kind of an overview talk introducing Pair to you and about the role of academia in looking at the field of physical AI, and specifically about foundational pairing of physical intelligence and physical world. Sorry, foundational pairing of digital intelligence and physical world deployment at Northeastern and beyond. So we have lived the world of LLMs for the past couple of years. Physical AI is now understood to be the next frontier beyond LLMs. And the goal here is to go from pattern recognition to model-based reasoning and control in the real world. Let me just, okay. And the application domains impacted by physical AI are many, including things that we may be pretty familiar with, like autonomous driving, advanced manufacturing, but it really impinges on many, many application domains, and therefore it speaks to the importance of this area. And PAIR, the Physical AI Research Initiative, is Northeastern's coordinated cross-disciplinary academic research initiative and platform in addressing the field of physical AI. And I'm going to go into more detail about what this initiative entails. Next. Okay. So, okay, this one. So why is everybody looking at physical AI? Well, AI has excelled in the digital domain in terms of understanding and producing text, images, and code, but still struggles in the real world in terms of understanding dynamics in the real world, causality issues, uncertainty, how to take actions reliably, efficiently in the real world. So the core gap is that AI models do not yet have a good understanding of the physical world. And in the last year or so, you've seen a lot of attention to being paid to this area by many of the most important companies and thought leaders in the area, including NVIDIA and Jan LeCun, World Labs by Fei-Fei Li, and so forth. And I like this quote by David Siegel, who's actually, he's an investor, but he actually worked on robotics in his PhD, that things which are trivial in the simulated world are impossible in the physical world. So there's a lot of emphasis and a lot of focus on this area of physical AI right now. So what is physical AI? I think there may be different definitions and understandings, but broadly speaking, our view of this is that we want to move from perception to world understanding to action. And physical AI systems which are informed by physical AI, should learn how the world evolves, be able to predict future states, make decisions grounded in physics, and be able to act safely in real environments. And so this requires a shift from pattern recognition to model-based reasoning and control. Now, the vision of PAIR, which is the initiative at Northeastern, is a future in which AI understands the physical world and works alongside humans to act in it. And the challenge that we face, as I mentioned, is this gap between AI models which exist currently and the real world. So AI needs to be grounded in physical principles. And the mission of PAIR is to pioneer the next frontier in AI systems to learn, reason, and act effectively, responsibly, and collaboratively with people in the physical world. PAIR has a couple of intellectual pillars. So Learning from the world, reasoning in the world, and acting in the world. Learning from the world pillar involves creating physics-consistent digital twins and generative environments to accelerate development, validation, and safe deployment of AI in the physical world. Reasoning in the world looks at fusing multimodal sensing, semantic understanding, and control to enable AI agents that can reason and act with foresight in dynamic and uncertain environments. And finally, acting in the world, we want to ensure that physical AI systems are verifiable, trustworthy, and resilient to uncertainty, and be able to enable safe interaction with people and environments. So these are the three essential intellectual pillars. Now, what makes Northeastern well positioned to pursue pair and look at physical AI? For a number of reasons. Northeastern is highly ranked in AI research. We have very prominent AI researchers in the field, and this particular initiative, PAIR, includes a lot of the top contributors to Northeastern's reputation in AI. We have expertise on pre-training image video generation and language models. We have unique research on reasoning according to physical laws, and you'll hear some of these the faculty who are experts in these areas in the talks which follow. And so now Northeastern, we're especially experienced in interdisciplinary research. So we really pride ourselves on being able to organize across different domains. So the pair leadership and the primary faculty which are in pair, they come from colleges of engineering, computer science, science, social sciences, and health sciences. And we have over 20 confirmed primary faculty members already working in the pair initiative. And we also have some very unique physical AI resources. So as I mentioned, the application domains of physical AI are very broad and impacts many areas. But the availability that we have of data in these areas is very valuable for us. For instance, we have the Coliseum wireless emulator, the biggest one in the country of emulation of wireless communications and networking, is sitting at Northeastern. We have the robotics and autonomy labs and the UAV labs at Northeastern. We have the Marine Sciences Center. We have the Stress Lab, which is a lab that captures a lot of data having to do with building structures. We have the Barnett Institute, which captures a lot of data on biological and chemical processes. So all of these are great resources which can provide not only the data for training world models, but also in looking at also be able to allow us to apply the physical AI systems in various domains. So this is just a brief snapshot of the primary faculty that are involved in this effort. It has a lot of the leading experts in AI and machine learning at Northeastern, but also many domain experts who are using AI and will be using physical AI in their respective fields. Now, the physical AI is now becoming a big focus for industry, and that's great. That's a great affirmation of the importance of this area. But what is the academic role in physical AI? We believe that there is a very unique role to be played by academia in physical AI, focusing on a number of different things. First of all, open academic infrastructure, shared data sets, benchmarks, reproducible frameworks, and have established platform for cross-domain experimentation. I think those things are very familiar with the Voxel 51 audience. The academic role is to look at foundational research in physical AI. In our case, learning, reasoning, acting in the real world, in real-world environments. Develop methods which are applicable across multiple domains. So industry tends to, of course, be more focused on specific directions, products, whereas we're interested in applying methods across multiple domains. Leveraging existing university investments, the university already has established institutes in many different directions, for instance, in wireless communication, in semiconductor manufacturing, and so forth. And what PAIR is doing can be very synergistic and complementary to them. It will serve as a great bridge to industry, so we'll use the academic platform to evaluate and extend industry advances. We can provide the workforce and curriculum development, which is very unique to academia. So training students and building the next generation of talent in physical AI, develop the next generation curriculum in physical AI. And also PAIR represents a very coordinated university scale initiative, which distinguishes it from efforts which are specific to labs. This is a much more comprehensive effort. In terms of application, as I said, there are many application areas which can benefit from physical AI and need physical AI. So the application areas we're currently focusing on include smart manufacturing, looking at simulation design frameworks to accelerate discovery and development, healthy living, how to leverage domain knowledge and the physics of devices for discovery and human-in-the-loop decision support systems. Also, in terms of dealing with extreme climate events, to be able to accurately predict the location and impact of extreme climate events, which involves, of course, understanding the physical processes that drive these events, saving lives and minimizing property damage. One of the things that PAIR is doing is developing our own open source academic world model. This is called New World, or NU World. NU is for Northeastern University. So there are, of course, many groups working on world models around the world. So World Labs, started by Jan LeCun, and so forth. NU World will be an open and physically grounded academic world model upon which everybody is allowed to build. And it will inform many application domains and will provide benchmarking and open source code. So just to talk about what we're doing next, PAIR is having a lot of momentum right now. It has a rapid build out of faculty and leadership. We have active technical development underway. We have growing industry engagement, including with Voxel 51, NVIDIA, Amazon, and so forth. The next milestone for us will be a launch event in May 2026, which will showcase early results from us, which will convene academia and industry around the country, and will position Northeastern in the ecosystem of physical AI. So we'll be in touch with more details as this event gets closer. So just to wrap it up, physical AI is the next inflection point in AI, and it requires new foundations of learning, reasoning, and acting. PAIR is the initiative that is organizing this effort academically at Northeastern at an institutional scale. There's great opportunity here to shape the future of AI beyond the digital world and bring it into the physical world. Okay, thank you very much.